My name is Dinesh Babu. I'm a software engineer by profession. So today let's look at how websites work. So let's look at the big picture of the web. So in simple terms, the data exchange between the server and the client is what makes up the web experience. A website is hosted in the server and is supplied to the client via internet. So let's look at it in a better abstraction. So first let's look at the client-server connectivity. The client and the server communicate via internet, whereas the internet connectivity to our homes is provided by an internet service provider, and this internet would arrive at our modem. And from our modem, the internet is distributed to our computers, laptops, and mobile devices through wireless means or wired means. And this is the connectivity part. So let's look at the communication part between the client and the server. So each server is associated with the IP address in the World Wide Web. The IP address is a unique address by which you can locate a server in the World Wide Web. And the DNS server holds all the IP addresses and the corresponding domain names. You could register your own domain name, or that means by purchase you can purchase your own domain name by from the DNS server and allocate a corresponding IP address. So whenever the client requests a page, the traffic will be directed to the server by the DNS server. So this is how the communication takes place. Let's look at something even more interesting. So HTTP, the Hypertext Transfer Protocol. This is the backbone of the entire World Wide Web. So it makes it possible for us to for the client and the server to communicate, in an asynchronous fashion using packets. So before getting into HTTP, we can have a look at TCP/IP. TCP/ICP, when expanded, it would phrase as transmission control protocol. So this is an early protocol introduced to transmit information between two computers in terms of packets, and it ensures the arrangement of packets in the right order in order to retrieve the message when the transmission happens. So, in other words, HTTP inherits these qualities from TCP/IP. That means when you transmit some packets using HTTP protocol ensures that the packets are transmitted properly, and it ensures they are arranged properly to retrieve the original message. Okay. So here in the diagram, you can see we make a HTTP request when we request a domain, and the request could be in number of packets based on whatever you request. Your request could be in it could be any number of packets, and these packets arrive at the DNS server where they are routed to the server, and the server arranges the messages and it tries to understand what the client is requesting. And if in case it wants to respond positively, it would actually for example respond with a status code, for example 200, and a number of packets, and these packets are rearranged in the browser, and that's how we see a web page. Okay, so let's now see how these packets become a web page. So these packets mainly consist of HTML, CS, and JavaScript, and also images and other assets. So when the browser requests a server for a file, right, it would be most probably a HTML file. The HTML file is the first loaded, and it's parsed. So the parsing is the act of the browser where it goes from the top to bottom of the file, translating in the sense translating everything to build an internal model. The internal model will be called a document object model. Okay, so it's called DOM. So when it traverses along the tags, it would actually stumble upon the link tag and script tag. If it's a link tag, it would see what it requests. So if it's a CSS, and if the script tag requires a JS, it would stop at these points and start downloading these files. And only when the download is complete, it goes to the next tag, HTML tag. And by this way, the HTML parser goes from the top to bottom, translating everything into DOM and also downloading all the resources that it comes across. So, and when the parsing ends, we would be having a a DOM created internally in the browser. So after this step, the HTML, after this step, the browser has the next task in the queue. So it will look at the CSS file that has been downloaded, and it will try to translate the CSS files into something called CSSOM. So this is the internal representation of the child sheets. And after doing this, it would concentrate on the JS part. So it would look at the downloaded JS, and it would try to compile it into an internal bytecode, and after that it tries to execute it. So in step 3, even before the execution of the JavaScript, you would be able to look at the page because it's HTML and CSS basically, right? So the view would be ready. But only after the execution of the JavaScript, you'd be able to interact with the page mostly, because JavaScript many times is used to manipulate the DOM, to modify the DOM. Okay, so let's look at a practical example here, which is quite simple and helps us look at some of these concepts we discussed in theory. So here I have a web page, a very simple one, and I have a local server running. And when I reload the page, you could see there are three in the currently I'm in the network tab. You could see there are a number of files here. When I click on the HTML, you can see something gets highlighted here. This is the packet for this HTML file, and in the same way I see the packet for the CSS file, and next the JS file. So you can see the packets have arrived, and the network tab shows it clearly, right? So yeah, and in case you want to look at the DOM, you could actually go to elements and click properties, and you can navigate your way around the DOM. Yeah, so this is all for this tutorial, and until we see in the next tutorial, bye.